Let us now take an unbalanced transportation problem of order 3 by 3, where we have 60, 70, 30 units at the origin and 50, 20, 40 units as the destination, what is called as demand, with the total supply being 160 units, then total demand being 110 units. So, the difference is 50 units. Since the total supply is greater than total demand, we introduce one more column with 0 cost. Okay. The other cost being the same 213, 321 and 123 as indicated in the table. Now, unlike the previous 2 by 2 transportation problem, let us solve this 3 by 3 with the initial basic feasible solution to be obtained with a Vogel's approximation before moving towards Modi method for optimizing. Okay. Now, as per the principle of Worms, we take least and the next least and put the difference in the bracket. Then 0 1 1, here 0 1 once again 1, then here 1 2 1, 1 2 once again 1, 1 3 2, then you have 0 0 0, among which 2 is the highest. So, if we go through in the third column, 1 is the least cost, where the demand is 40 and the supply is 70. So, we can supply all the demand and the demand column can be crossed. Then once again, if we go for differences, this is 1 only, but this is 2 and this is 1 only, and again no, nothing is crossed here, and again you keep up the same, for which this 2 is the highest and the least cost being 0, where the demand is 50, but supply is 70 minus 40 is 30. So, I can supply 30. So, let me remove this supply column now. And once again we have to find the differences. This 1 is okay, then 2 minus 1 1, here 0 minus 0 0, then here 1 minus 2 1, then here 2 minus 1 1, right. So, among which we have to choose the highest. The highest is 1 only, now it becomes optional, where if you choose this one, the demand being least cost is 0. So, demand is 50 minus 30 20. So, 20 can be filled up. So, this column can be crossed. Then once again difference is 1 only, here this is taken off, this is 1 only. So, this is 1, this is 1, everything is 1. Now, we can choose no allocation. So, we can choose this one to be highest because all are 1s. Now, we have least cost in that row is 1 unit, where the demand is 20, but supply is 60. So, I can supply entire demand. So, this column will be out. Then you have got only one column where the lowest cost is 1 and the demand is 50 units. Supply is 30 minus 20 is only 10 units. So, I can supply 10. So, 10 plus 20 30, this is crossed. Then only one soul is available, where the demand is 50 minus 10 40 and the supply is also 60 minus 20 40. So, I will fill up this 40 to compute this. Now, what I do is I go for next table. So, how many allocations I have? 1 2 3 4 5 6 allocations, 3 plus 4 7 minus 1 6 allocations. So, 6 basic cells are satisfied. So, let me put 40 here, the cell cost being the same. So, now moving towards Modi method. Now, for this Vogel's approximation method, what is the total cost? So, 50 70 150 is the total cost. Now, moving towards Modi method, let us first fix UI and Vj now, where the higher number of cells occupied is of all the 3 columns. So, let us take first column, this U1 as 0. So, for basic cells we have to apply the rule in minus out, 1 minus 0 1, 2 minus 0 2, right. This is also a basic cell. So, 1 minus 2 becomes minus 1, 0 minus half minus 1 1, 0 minus 1 minus 1, 1 minus half minus 1 2. Now, all UI and Vj's are filled. Now, we have to go for non-basic cells. 1 3 is a non-basic cell. For non-basic cell allocation, we have to have out plus out minus in. So, 2 plus 0 minus 3 is negative quantity, 1 plus 0 minus 1 is positive 1. So, 3 2th cell is also non-basic cell. So, 1 minus 1 0 0 minus 2 negative, 2 minus 1 1 1 minus 3 negative. So, all the non-basic cells now done. 2 comma 1 is also non-basic cell, 2 minus 1, 1, 1 minus 3 negative, 1 minus 1 0, 0 minus 1 is negative. So, all the non-basic cells are negative excepting 1 comma 4. Now, we have to start the loop from 1 comma 4. Then if I can turn here, then I cannot turn there. So, only possibility is I have to come here, then go there, then come here, then come here, right. If you keep this as theta, this will be minus theta, this will be theta, this will be minus theta, right. Now, minus theta minimum is 20. We have to shift this with the help of these 20. The other cell costs are 20 being the same as it is, 40 being the same, 30 being the same, 40 being the same, 30 being the same, right. Now, I have to go for the internal cost are 130, 1230. Now, once again we have to go for ui and vj, where the original place of fixing 0 needs to be there itself 0. Then for all basic cells in minus out 0 minus 0 0, 1 minus 0 1, 2 minus 0 2, 1 minus 2 minus 1. Then we have 0 minus 0 0, 1 minus 0 1, all ui and vj's are fixed. So, if I go for non-basic cells, 1 comma third, that 0 is 1 plus 0 minus 3 is negative, then 2 comma 1, 2 plus 0 minus 3 is negative, 2 comma 2, 1 plus 0 minus 2 is negative, then 3 comma 2, that is also non-basic, 1 minus 1 0 minus 2 negative, then 1 minus 1 0 0 minus 3 negative, 0 minus 1 minus 0 negative. So, all becomes negative here, all Zj minus Cj are negative. So, what happens for the iterative table? Now, we have come to optimum table. Now, what is the optimum cost associated with this transportation problem, unbalanced transportation problem? Then 130. 130 rupee is the minimum most transportation cost, whereas Vogel's approximation method ends with a cost 150, among which 130 is minimum. So, optimum transportation cost for this problem turns out to be 130 rupees. Okay. Now, next we can go for maximization problem in transportation, that will be covered in the next class. Thank you.